Hi. So today I'm gonna talk to you about putting containers to sleep and, more importantly, wake them up even faster. So let's get started. Give you a list of contents. I'm gonna introduce myself, talk about a bit about the motivation for this talk and this project in general. We'll have a quick look at some existing solutions. Then I'm going to show you a live demo and then talk about a bit of the technical details of the implementation and then give you an outlook into the future. So, short intro, my name is Cyrill. I work as a platform engineer at Nine. We're a company based here in Zurich, and we do all kinds of infrastructure provisioning with Kubernetes, and our customers are any company that needs some kind of cloud hosting. We also built a backend for an app development platform called Deployo, sort of like a PaaS solution. Yeah, and on the side, I'm always exploring new and interesting technologies. And this is also how this started. This is just a side project of mine. Yes. So, quick motivation. This is a rough quote from a coworker, Tom Whiston. He said something along those lines: if only we could scale this to zero, we could save resources, money, and so on. And that got me thinking a bit, is there something like this out there on Kubernetes? Yes, and I already had some previous experimentation done with container checkpoint restore, which everything this is based on. So I had some rough ideas of how something like this could be implemented. And I needed another excuse to play with eBPF. You constantly hear it at conferences, right? So I wanted to get my hands dirty and actually do something with it. Also found this really interesting article from Cloudflare. It's essentially about TCP proxying with eBPF, but in the end I didn't actually use this, but it's really interesting if you're curious. So, some existing solutions. Well, first of all, there's a closed source solution that Heroku offers. If you have the Echo tier of an Heroku app, they will shut down your application, I think like after an hour or some specified amount of time if there's no traffic coming in, and then you notice it if you make a request, you will notice that it takes a bit longer to get it up, but it's, I don't know, a second or two. It's pretty fast, so I thought that's pretty cool. So is there something like this that's open source on Kubernetes? So I stumbled upon the Keda HTTP add-on. Keda, if you don't know, is a scaling solution generally for Kubernetes, and there's a little add-on that they have on GitHub, which basically starts a layer 7 proxy and then sets replicas on demand. So that the layer 7 proxy knows, okay, a request came in at that point in time, now there has been 5 minutes without a request, set replicas to 0, and your pods will be gone. State is lost when you scale to 0 because it will delete the pod, so all in-memory state is gone, and yeah, pod startup latency becomes very relevant. It depends very much on your application, how fast can it start. If it starts quickly, like a small Go app, this won't be too much of a problem, but if it's a bigger application, you will notice this. Image pools can make things worse, of course, because your pod might get scheduled on a new node that doesn't even have your image yet. Knative, very similar solution. It also creates pods on demand, but in general, Knative is a huge project. This is just like a really small piece of it that you can actually scale to 0. It works a bit different. I think it also deploys a sidecar, a proxy sidecar, and like a central proxy. The architecture is quite complicated, and in general, it's quite a beast to configure. But yeah, I managed to set it up and play around with it. And yeah, notice it's really similar to Keda with the same sort of drawbacks in the end. So yeah, I have a small demonstration of what that looks like for Knative. You see in the bottom, you see my pods, and you see that I watch the pods, and whenever I make a curl, let's play it again, I watch the pods, I make a curl in the top, and then you see the pod starting up, and after 2 seconds in this case, I got my request back from Nginx. And Nginx is software that starts super, super fast, so this will be worse if your application is bigger. So, before I dive into my solution, I just want to give you a quick rundown of the architecture of kubelet and containerd, because it's going to be relevant afterwards. So on the left, you have the kubelet. Kubelet talks to the CRI plugin, and the CRI plugin in this case is containerd. And containerd will then, per pod, start a containerd shim. You see this in this little box here, and this is going to be relevant later. And the shim is responsible for creating the sandbox, the C groups, all that sort of stuff. It actually just calls out to run C or C run or whatever to do that stuff. So it's just an in-between gateway between containerd, the runtime, and something like run C. And yeah, it also provides stuff like logs. So it makes pipes for the logs, and it also makes stuff like exec possible. So if you exec into a container, the shim binary will actually be executed and receive a command. And this is the part of the architecture that I've modified so far. Yes, we'll have a look at that later. So, without further ado, I want to quickly show a demo so you guys know what I'm talking about. Let's switch over here. So I have a simple cluster here with a node. This node has my little shim plugin installed. I have also a, let me switch to the demo folder. Yes. So I have a little WordPress application deployed here. I'll just quickly print the YAML. Nothing too fancy. It's just a PHP pod, a service, and a database where the WordPress instance connects to. And the only thing that's special here really is that in my PHP deployment in the spec, I've set the runtime class to ZeroPod. ZeroPod is that project that I'm working on. So I can also say get runtime class, and I see my ZeroPod runtime class is installed. And I see the pods. I got my database, and I got my PHP pod running. Down here, I'm SSH'd onto the node. So I'll just quickly show what a normal run C process looks like. I'll make this bigger. Hopefully you can see it. So usually, what I talked about before, you have that shim binary. That's the thing here. So containerd shim run CV2. The shim binary has child processes. The pos container, I don't know if you know about the pos container, but it's essentially just there to provide the C groups. So if my SQL here dies, that the C groups won't get destroyed, because in Linux, if you destroy all processes that are part of a C group, the C group itself will be destroyed. So that's the reason for the pos process here. And yeah, you see the actual container here, MySQL. So now, what's interesting, I have this run C processes, right? And I have, this is also just a script that does PS and filters. And here you actually see my containerd shim ZeroPod, and you just see a pos container, nothing else. So now, I'm also gonna open this. So I'm gonna actually just paste some, output some logs here. This is just so that you can see what's happening in the runtime. This is just the event daemon that receives events. So I'm gonna open, sorry, I didn't show that. I have an ingress. So it's reachable here, and I'm gonna actually just open this site, and then you see what happens. Oh. Yeah, so what you saw happen was the container was scaled from 0. It's now running. And let me just make sure it doesn't scale down again. And now you see my process list has changed. I have now the Apache running here. So it's Apache and then PHP inside that. And as you can see it from the log message, it has automatically scaled down again because there was no requests. And the process is gone again. So yeah, I can do this basically all day. Just restore, it's running, click around, and yeah, then it will automatically scale down again. Yes, oh, I almost forgot. I got one more thing to show. So this is something you should only try at home. Don't try this at work. So I have my spec here for the database, right? So I'm just gonna do this. Name. I'm also gonna set this to 0pod. Oh. So my SQL container is restarting with 0pod. And yes, that's it. And you see already here in the log, attaching redirectors, something happened, it detected something. I set the scale down time to 10 seconds here, so it should scale down pretty soon, hopefully. Let me quickly check here. Oh, it already did it, okay. I think it already did it. Let me just, I think it's just the daemon here that's not responding. Can happen sometimes. So I'm gonna restart this. Yeah, okay. It received events, so my SQL was scaled down as well. So what do you think happens if I actually open this page again? Let me make some new lines here. So I'm gonna refresh, and it still works. So what exactly happened? Now you see those log lines. It first started the PHP pod, and then PHP made a connection to the database. Because I can use also TCP to actually start containers, it then started the MySQL pod from scaled down state, and it's now running as well. And it already scaled down again, so you won't see it here. Maybe I gotta like refresh so you can actually see it. Refreshing. Now MySQL is running again. So yeah, that's that. Now let's get into some of the details. What do we get with this? We get sort of serve on demand with a sub-second delay. This, of course, has an asterisk. It very much depends on the size of your application, on the resident set size, so the in-memory size of the application, and also on your CPU and storage. So the whole memory of your container is checkpointed to disk, so it matters. The disk speed matters a lot. It retains state when scaling to 0, so I don't actually. Technically, if I have some state that's in my application that happens during initialization, that doesn't have to happen again. That's why I can restore pretty quickly. It only proxies requests during restore, so there's no layer 7 proxy in front of this. This was just standard ingress. I can also do a port forward. It works because we'll get to it later how it works, but yeah. It supports raw TCP, as you've seen. It's not limited to HTTP. You basically need to make no code changes. You just add that single line so that 0pod is used as the runtime. And the scale down configuration, duration can be configured. So some use cases for this. These are just use cases that I made up, but essentially low traffic apps is something I could imagine using this dev staging environments that only need to be running during work hours. Yeah, and it's configurable how long it will take until, like after a request hits, how long do you wait until you want to checkpoint again. Yeah, maybe mostly static sites that still need some server component, that still need some API. Yeah. So technologies, well, as you've seen already, Containerd and runc are two important parts here. So the container, in the end, the running container will be the same as any other runc container. I'm still using runc. For checkpointing and restore, I'm using Cryo. That's like the one tool. It's built into runc actually, so I didn't have to implement any of that. I just had to build the Cryo binary, put it in the right place, because that's not shipped usually with Kubernetes clusters. And yeah, watch any talk of Adrian Reber. I think he was here last year. He did a talk about this tool actually, and there's some interesting things going on there. And last but not least, eBPF. So I'm going to talk about this a bit more, but this is how I get that proxy-less solution, basically. So architecture. So here in the upper left, we have any ingress. As I said, it could also be a port forward or something like that. It could be a service type load balancer. It doesn't really matter. It's just traffic to the container. Then in the kernel, there's this redirector eBPF program loaded, and this will make a decision based on the state of the application. So if the application is checkpointed, it will rewrite the packet to change the port, and then the port will be of a little Go proxy that runs in the zero-pod shim. That little Go proxy will accept the connections and then actually do the restore. And while the good thing about this is that the requester here, the user, will the connection will be accepted, so it won't, no traffic is dropped essentially. And then we can, as soon as the process is running, so this will always try to actually connect back to the application every millisecond. Once it's running, it can proxy that first request, can proxy that first request to the container. And afterwards, I can just flip the switch here in the redirector eBPF program, and now the traffic will directly go to the app. So yeah, that's pretty nice because I can just do this in the kernel, nothing else needed. Yeah, and then there's another little eBPF program that I'm not going to go into too much detail, but that just basically observes when was the last request. So I need to know when I can actually scale down again, so there's a little probe that monitors that. And yeah, this is all using eBPF maps. I don't know if you know about this, but essentially it's a way to communicate with user space. So the zero-pod shim can actually just read out that map and make decisions based on that. So one other important thing that I ran into during this whole thing, shim memory usage. So that shim process that you've seen, it runs once per pod, meaning that memory usage becomes really important. And it's also something that Containerd has tweaked over time. They realized they really need to take care of what you import. So it's written in Go, and sometimes if you import some package in Go, that package might do something in init and will allocate memory. And that's something I realized. I had like a single constant imported, which imported API machinery. Yeah, in the end I figured that out, that it was that, and just moved that constant into my own program, and we're good. Loading eBPF programs is also very memory intensive. It will free that memory again if you tell it to, but this is also something I didn't know in the beginning, and I'm actually doing it outside of the shim. Oh, I haven't actually shown this. There's this zero-pod node daemon that runs on every node just once, and it actually does the loading of the eBPF programs, and it's also the thing that receives these events that you've seen before, and some metrics. And there's a little thing called grouping. I'm not too sure about that yet, but I found this in Containerd. So you can set this little key here, and then multiple pods can use the same shim. So in theory, that sounds pretty good because now we can group pods together, and you have just the overhead of one single shim. Of course, one downside is if your shim binary dies, all the containers will be affected using that shim key. I'm also not sure if there's any other security implications. There's an open question about this in the Containerd GitHub. I asked, but I didn't get a reply yet. But yeah. But as far as I can tell, it creates the same amount of C groups, so the individual containers should be isolated as usual. Should. So now you might be asking, when you scale down a container to Kubernetes, it appears like the container is still running. It's sort of that hacky workaround I had to do to make this work. So Kubernetes thinks the pod is still running, but what do you do actually with the resource request? So if an application requests 100 millicores, and here in this example, 128 megabytes of CPU, you actually want to scale that down as well. And there's a nice feature flag with, as of Kubernetes 1.30, it's still behind the feature flag. But if you enable that, Cyrill pod will automatically patch the pod requests on scaling events. So what's next with this? There's a big release coming up for Containerd. I think they have a release candidate 2. Yeah, release candidate 2 released right now. I already tested it. It works fine. But there's some new features that might be required. So for example, there's user namespaces support that will come with Containerd 2.0. And to make that work, I actually need some changes in my shim to adapt to the new Containerd version. But there's another issue with user namespaces. I tested it so far and couldn't get restores to work. I think there's an issue in Cryo, so it wouldn't properly restore user namespaces. Checkpointing worked, but restoring didn't. But yeah, I didn't really have time to look into it too much. Also, adoption at 9. So as I mentioned before, we manage a certain amount of clusters, and I think there could be some use cases here. And yeah, I think adoption is the only way to figure out if this is actually useful. And hopefully some of you guys will actually try it out. Compatibility testing. So far, everything I threw at it kind of worked. So as you've seen, I had a PHP app. I have MySQL. Don't do this. I also tried some Go apps, I think Nginx. So I tried a bunch of apps. I have also had Ruby app. Yeah. So far, everything has worked except for a Node.js app which uses libuv. I'm not into the Node ecosystem too much to know if this library is really used much. But yeah, it uses IO-Uring, which is a kind of a newer kernel concept. And Cryo doesn't support it yet. There's a PR open for quite some time now. We'll see what happens. Eventually, Cryo will get support for it, and then Cyrill pod will automatically get support as well. Yeah, I put all the resources and links I mentioned in this talk here into this slide, if you're interested. Also, there's a little detailed Containerd architecture. Yes. That's it. The project is hosted on GitHub, so all the code I talked about is on there. Check it out. It's super easy to install on a local kind cluster just to try it out. Yeah, that's it. Thank you very much for attending, and if you have questions, you can ask them.
Yeah, there's a lot of questions.
Cool stuff. Thanks a lot for preparing this. I see a lot of potential for it. So 2 questions. How many people are actually working on it? Is it a one-man show? Or is it, yes?
It's just me.
It's just you?
Yeah,
okay.
it started as a side project, so not even at work. I just hacked around in the evening, basically.
Okay, cool. And any plans to submit it to CNCF or so, that you get proper support?
No, not yet.
No, okay.
We'll see. I think there needs to be at least some users, and we'll see after this if there's someone who's interested in it. And, yeah.
So it's super early stage now?
Yes, pretty early stage.
Okay, good.
Yep.
Sorry, thanks for the talk. I was wondering, do you have any plans to sort of extend that mechanism to whole clusters of Kubernetes clusters? So doing like cluster autoscaling in the same fashion? Have you thought of that aspect?
Not too much. I mean, the thing is, if you set the resource requests down, eventually the cluster autoscaler will notice like there's nodes that have way too much, or like these pods could fit on less nodes. So it will start shuffling stuff around, right? It will delete a node, for example. And there's sort of an issue there because what happens is the pods that are scaled down will be scheduled onto a new node. They will come up shortly, and in that time, they need more resources. So there's some tricky stuff there. So I haven't completely solved that yet.
Cheers. Thanks.
So you said it also works for TCP connections. So will it let sort of the first TCP, I guess, SYN-ACK wait until? Okay, so there's no large data build up in the shim.
Yeah, no, there's not. Actually, it just does a TCP accept, and then it will do nothing until the process is restored, and then it will, of course, it will have to shuffle this first request back and forth.
Yeah.
So that's what the shim needs to do for the or other requests that came in during restore. Yeah.
Okay, thank you.
So thanks a lot for your talk. If I understood correctly, while sleeping or shutting down state, you basically store a snapshot of the memory to local disk.
Yes, exactly.
And then you're basically on wake up, you just copy the content again into memory.
Yes, so that's what Cryo does automatically. I just set the restore command to runc, and runc will call out to Cryo, and it will do the whole restore.
Okay, and how does it handle it if in the meantime you do not have enough memory to load the state again?
Yeah, I guess then it will crash. Yeah, I mean that's the nature of it. I think it will probably run out of memory, and your restore will be canceled.
Do you need some handling on disk space to store the state?
Yes, I think disk space is kind of okay because Kubernetes already has that implemented, right? That it will detect if your local disk space is low on memory, and it will mark the node as disk pressure. So I think that's already fine. Yeah.
Okay, but as you're modifying the requests, the schedule of Kubernetes will not notice that you have less.
Yes, I think.
You need.
Yeah, I think. Eventually, if you have, let's say, you have hundreds of these pods on one node, I think what you will need to look at is how many of these get waken up at what intervals, and then take that sort of average usage, and then you might notice, okay, I have a bit too much on this one node. Maybe I'll remove some. It will really depend on how often your application will be restored.
Thanks a lot.
Yeah.
So thanks a lot for the talk. A quick question: you mentioned that the first connections goes through the shim, and then how does it happen if this connection is a long-lived connection? For example, what happened inside the eBPF redirector? How do you route the long-lived one, the first one that goes? Does it continue to go through the shim and the new ones directly to the pod?
Yeah. So after it has restored, the eBPF program will directly will just flip the switch essentially, and new connections will go directly to the pod, and all connections that were happening during the restore go through the shim. Mm-hmm. So yeah, it just TCP accepts and then waits essentially. And of course, if your client has a low, the connect timeout is not a problem. If your client has a low, receive timeout, it will cancel out eventually. Mm-hmm. Yeah.
Thanks. If you have some applications that are stateless and very fast to start up, would it make sense to use the horizontal pod autoscaler instead of this, for instance?
Yeah, I think if your application is really quick to start up, horizontal pod autoscaler makes a lot of sense for sure. Here, the good thing is just that you can scale to 0, right? Yeah.
Thanks for the talk. I was wondering, you are listening to connections, but let's say you have something that's handling connections, and then you have a secondary, let's go with the sleep 3600.
Mm-hmm.
How is it reacting to that? Will it notice that it has a time offset?
You mean like an open connection, or?
No, I mean like the linearity of time. Will it panic from that, or does it just not matter?
I think you mean if the application just sleeps?
Yes.
Yeah, it depends. I think if it
or in general, just you have a process that is not that is maybe spawned by the initial connection and has some work, which takes longer than your scale down timeout.
Okay.
Will it freak out? Will it just resume as nothing happened?
Yes, it should actually resume where it left off.
Okay.
Yeah, because everything in memory is retained, right?
Okay.
So your sleep will resume where it was before. Yeah.
Okay. Thanks.
For some more, let's say, more complex stateful applications, normally there's some sort of callbacks to dump some state or, restore it. I assume CRY provides you with this thing, right, or not? So let's say you have some socket, you have like file lock, like
okay,
like those are not.
Yes, so CRY can pretty much checkpoint and restore everything. So file locks, I'm not 100% sure if it can handle them, but most of the stuff should be handleable. I had to disable a few things, but yeah, usually it can pretty much restore anything. It should also be able to restore running connections, for example, so open TCP connections. If your IP stays the same, I think it can do that as well.
But for the cases, there can be cases that cannot be restored. So in those cases, is there some sort of callback into the app to do
no,
that?
if it can't restore, there's not much we can do.
Because
so that will just
other similar systems, they have this notion of the app gets a call to do this safely. Like let's say you are a database, so you want to synchronize a transaction log and then.
Yeah, something like that. It's not implemented.
Yeah.
Generally, CRY is very application agnostic, right? It doesn't really know about the application itself. It just takes the memory contents.
Yeah. Cool. All right, thanks.
One last question.
I'm wondering how do you keep the state of how long is my application idle? Let's say you have 10 pods, right? And suddenly it's just idle. How does zero pod, where does it keep? Like that was the last one active and then I decided to put everything to zero or?
I mean, you mean if it's idle for a long time?
You have 10 containers, right?
Yeah.
Your application, sorry, maybe I was not holding right. And zero pod, as I understand the eBPF is per container.
Yes.
But how does it know holistically that from all of those?
No, it's not that smart yet.
Okay.
So basically, it still uses Kubernetes load balancing. So if you have 10 replicas and they're all scaled down, Kubernetes will just pick one. This container will receive traffic and start up.
Okay, perfect. Yeah. Thanks.
Okay, we're going to wrap this up. I'm sure Cyrill will be happy to answer any more questions during lunch break or later on. Thanks so much, and another round of applause for Cyrill.